This is video number 10 in the series of tutorials for building our Drive app, and it's also the second one in stage 4. In the previous part, which was the first one in stage 4, we got up to we completed step number 7 in the stage 4 guide, and we're up to step number 8. So we have a container called water container, and we're going to add a plane to it as a child. Not as a child of WaterViz, but it's going to be the second child of water container. Its name is going to be splash detector. So let's do that. Water container, 3D object, plane. And it's right now really, really small. So it's a sibling to WaterViz. And its parameters are going to be all zeros. The only thing we're changing is a scale of 100 on the X and 100 on the Z. Y stays 1. Why is it enough for the splash detector to be 100 by 100 while the water is like 1500 by 1500? First of all, because it's a plane. A plane is already 10 times bigger than most objects. It's already 10 by 10. So really making it 100 by 100 is making it 1000 by 1000. And also it's because it's going to detect us falling from the track, and the track is not that big. So 100 by 100 is going to be, plenty. So let's do that. It's all zeros except its width is going to be 100 and its height is going to be 100. Notice that I can't really see it much because it occupies exactly, I'll be able to see it only if I disable the WaterViz for a second. And that's like, that plane that I'm creating. But it's, look at how big our track is. This plane is going to be, we're never going to fall that far away from the track. The other thing that it says is that we don't even need to see it. So the splash detector, disable its mesh render so it becomes invisible. So mesh render, invisible. So it's there, but it's invisible. The next thing we're going to do, the whole point of this is like a little box or a net that we're going to fall through, like tear through. So in order to do that, what we're going to do is delete or remove its existing mesh collider. I'd rather delete and instead add a box collider. It needs to have a little bit of width, because otherwise if it's as thin as the plane itself, we might go through it between frames and it won't detect. But if it's at least 1 meter thick, there's no chance that we can go through it without detecting that we collided with it. So let's do that. So it's going to be 10, 1, and 10. Everything else is going to be, the same. Splash detector. Its mesh collider we're going to remove, and instead a box collider. And going to be 10, 1, and 10. Everything else is pretty much nothing. Let's see if there's any changes that need to be made. Nope, that's pretty much it. Just the, 0, 0, 0, 10, 1, 10. 0, 0, 0, 10, 1, 10. If I look at it from the side like this, let's see if I do it without, and I edit, you can see that it's a very, when I get close, you see how it likes a very thin, think of it as like a thin piece of cloth that we're going to just tear right through. Now, in order to tear right through it, let me show you. If I leave it the way it is right now, it'll just go right through it. But what I want is to go right through it, leave it in place, and still detect the collision. So the trick is going to be something like this. We're going to add a rigid body to it, and its parameters, you see, this is the only one that looks weird. It's actually 0. If when I type 0, it replaces it with, this is like, the closest thing to a 0 mass that it can have. And the other thing that we're going to do is collision detect and continuous, and freeze its position. I'm going to add a rigid body. This is all added to the splash detector. The rigid body, again, is going to have 0 mass. If I type 0 enter. See how it does that, 1E dash 07. It's going to have collision detection continuous. It doesn't need gravity. And as far as constraints, I'm freezing. In other words, doesn't matter what falls on it, it's not going to move. But because it almost has no mass, think of it as like the thinnest piece of cloth or the lightest piece of, like styrofoam or whatever hits it falls right through it. And that's the whole point. So let's check about these and see if there's nothing else to check here. It says that to test it, we're going to play fall on purpose, and it should fall right through and hit the ocean floor just like before. Before we add, there's a script that we're going to add. So right now, if I play, what should happen is that if I fall on purpose, I am going to hit the ocean floor, go right through it, and I'm under the ocean floor, and I just hit the water surface, and then hit the water floor. The ocean floor. Let's do it again. I'm falling and hitting the water, then the floor, and 3 seconds later, resurrected. Stop. What I want now is to add a script that is going to do a nice splash. And make sure that it does a splash only when I hit it the first time, because the car has like 5 colliders, like the wheels and the body and so on. I want only the first one to trigger a sound. That's one splash is enough. So first of all, we're going to add to splash detector an audio source with the resource called water mixdown, which is like like a splash sound. So splash detector. Making room, add component, audio source. The resource is going to be water mixdown. This thing. I don't think, of course, it's not going to play on awake. It's going to be waiting for, to be triggered. Uncheck play on awake, all else default. And then to splash detector, we're going to add a script called hit water splash, exact name, capital H, capital W, capital S. Make sure that it's in the My Scripts folder, and this is attached to the splash detector. And you're going to open the script and replace its default code with this. So assuming you're going to pause the video and type, I already did. Hit water splash. Here's the script, and I'm attaching it to splash detector, or I could have just created it as a component here. Now, if we open it, here it is. Hit water splash. Its job is to detect that we hit the water and trigger a sound. So assuming that you're, already typed the code, let's explain. The only library we need is the Unity engine, and the public class, of course, is the same name as script, and it has a start and an on collision. On start, I'm simply making sure that this Boolean that we declared way, long ago in our drive main script, did hit water false, is reset to being false. Because we might have reloaded the scene or whatever. I want to make sure that it hasn't hit the water yet, or in other words, reset. And then the rest of the script is on collision enter, in other words, when there is a collision, and of course the collision will be with my player. The object causing the collision, so collision is the event of colliding, my player is the object that caused it. So the first thing it's going to ask is, hey, what hit me? Are you the one with the tag player? We have already done this with the ocean floor. Very similar. If myPlayer.GameObject.CompareTagPlayer, make sure that it's a capital P because that's how the tag is spelled. In other words, yes, it's the player that hit. Then it's going to check one more thing to say, oh, if there's a collision and the application data dot did hit water false, that means that it's the first time that we hit, because it's, from the beginning. The print hit water is just for the console to see that it gives me, the messages that I want. Get component audio source dot play. The audio source is attached to this object and it tells it, hey, it's time to play the sound. Play the sound. And one more thing, inform the application data that now did hit water is true, so it prevents triggering it again. Let's say when two wheels just touch the floor, only touch the water, only one of them will trigger the sound. So this is the end of this if statement, the inner one that asks, if did hit water was false, and this is the end of the one that it's nested into, which asks if the tag is player. This is the end of collision enter, and this is the end of the class. Now, reading the guide, we're going to test try to fall. When going through the water, you should hear a splash sound. Let's see. If I remembered everything, splash detector has the hit water. Let's see if my speakers are on. If I drive off of the cliff, fall, sure did. I'm going to stop for a second just to show you all those console messages. When I play, all these I can, clear. But when I play, I should get 3 messages in sequence. First of all, hit, which is reported by the water. Hit water, hit the floor, and after 3 seconds, reload. So hit water, hit the floor, reload. All those are in the script as a print. If that all works, great. I think you would agree with me if I do this one more time that the one thing missing is that underwater look. When I go underwater, it still looks like air. I feel kind of like I'm underwater, but not really. It would look a lot nicer if I was really underwater, or look like I'm underwater. And generally, to get that underwater look, we need a visual underwater effect. The first thing we're going to do is make sure that we're going to do a few steps, and then I'm going to start a new tutorial just for the script that we're going to add. But let's do those first. First of all, make sure you have in your hierarchy a global volume. If not, you can add one by right-clicking on the hierarchy and from the category volume, adding a global volume. Chances are that you already have one because it came with the empty scene that, started the whole thing. But if not, I can right-click and volume and add the global volume. Just make sure you have one. We don't need more than one. For right now, it stays the way it is. We're going to mess with it a lot later on. The next thing we're going to do is open and select the center eye anchor, which is the center camera inside our OVR camera rig. And in the inspector of the center eye, in the category called rendering, we're going to check post-processing, basically telling it, hey, I'm going to add some filters to you, and I want you to use the global volume to do that. So it's just a checkbox. We just need to find it. So inside the player, I have my OVR camera rig. Inside my OVR camera rig, open it. Here's the the center eye anchor. And in the category rendering, there's a checkbox called post-processing. Right now, it's not going to do anything. I mean, it might look like there's a little bit of a difference because the global volume has some default effects, but we're going to take care of that. Here it comes. Select global volume. In its inspector, we're going to uncheck some default effects that it has, which are tone mapping, bloom, motion, blur, and vignette, because we're going to add others. So global volume, see how it has tone mapping? I'm unchecking. Bloom, unchecking. Vignette, unchecking. Whatever effects it came with, I don't want, because we're going to add different ones. In the inspector of global volume, we're going to click the button that says Add Override, which might as well, I think in the past it was called Add Effect. It's just the same thing. Post, not prost, but post processing. And something called depth of field, which is really focus. And we're going to give depth of field these parameters, which really are enabling two checkboxes, bokeh and focus distance. Let's see what that looks like. Select the global volume, add override, post-processing, depth of field. It's the only one that's enabled. Mode, of course, is not going to be off, but bokeh. The focus distance, look at what's going to happen when I do that. When I change it from 10 to 0. Was it 1.5? Is it 0.15? Yep. Mode bokeh, focus distance. It means that only objects that are 15 centimeters away from us are going to be in focus. And everything further away, it's like being, very short-sighted. If I start increasing this number, it brings into focus things that are further away from me. But if it's only 0.15, only things that are extremely close to me are in focus. Everything else is out of focus, and I'm starting to get that underwater effect. Of course, we're going to have to turn it on and off, so when we're above water, we don't get that effect, and when we're underwater, we do. But first, we create that effect. The second thing I'm going to do before this part of the tutorial will be over, so it should look like this, we're going to add another effect, which is called color adjustments. In the color adjustments, you're really only adding a blue color filter. We could do so much with this, but in the color adjustments, we're going to check color filter and add this, magenta color. I think that's the only thing we're doing, and it even tells you, kind of what color I got, because that's kind of like the color that you get, when you're underwater. Everything looks kind of, bluish. So, add override, post-processing, color adjustments, and in color adjustments, I'm going to click color filter and change the filter to this kind of aqua color. And if that's too light or too dark, I'm going to adjust it till it looks like. Now I got two effects that are happening together. I got blur and kind of watercolor. So I'm getting that, kind of underwater, color or effect or whatever. I can also play around with the exposure, making it lighter or darker. I like this one. So right now, with the two effects, the game window should look something like this. And does it? Yes, it does. If it feels like it's not blurry enough, you can always go back to the depth of field and reduce the depth of field, the focus distance. I think the number I chose is definitely good enough for me. I'm going to stop this tutorial here because the next thing we need to do is write a script that will detect whether we are underwater or above water, and tell the camera to turn on those effects or turn them off.